What up guys, welcome to the science video, the second video of the day. I did that completely wrong. What up y'all, this is Core from Final Notice Media. Welcome to the second video of the day, the science video. Because who doesn't like a little bit of science? And who doesn't like quantum entanglement and trying to understand things that might be constantly changing just when you view them? I dig this stuff, I think it's amazing. So this article is brought to you by Science News. Science News is there for you, and I gotcha. So if you're listening, go ahead and just chill out, drive your car. But if you're watching me, you can go ahead and read along with me. So let's go ahead and jump into this bad boy, because it's not too long, but it's a bit longer than what I like. New quantum physics, particle physics. An experiment hints at quantum entanglement inside protons. LHC data suggests that the subatomic particles constituents quarks and glutons share weird links. So that is the whole title of the article. I know it was a long one, but bear with me here, okay? The author of this article is going to be Emily Conveer, and this was just released around May 17th at 11:11. So super new, super updated. I know you like it. So in this picture it says tied up. Protons contain smaller particles called quarks and glutons that are illustrated in this image. Experimental data hints that quantum entanglement links those particles with one another. Protons are complicated. Protons are very complicated, but not as complicated as some of my relationships. The subatomic particles are themselves composed of smaller particles called quarks and glutons. Now, data from the Large Hadron Collider hints that proton constituents don't behave independently. Instead, they are tethered by quantum links known as entanglement. 3 reports on a paper published in April 26th at the xiv.org state this claim. Quantum entanglement has previously been proved on scale much larger than protons. In experiments, entangled particles seem to simultaneously influence one another, sometimes even separated by distances as large as thousands of kilometers. Although scientists suspected that entanglement occurs with a proton, signs of this phenomenon hasn't been experimentally demonstrated inside the particle, which is across trillions of millimeters, which is crazy small. Like, this is a super insane small. Bear with me. I was out of the green screen for a second. So, I mean, we're talking about the most smallest of details within this quantum entanglement theories and the experiments that they're trying to run. The idea is this is a quantum mechanic particle which, if you look inside, it itself is entangled, says theoretical physicist Piet Muller of the Vereen Institute in Amsterdam, who was not involved with this research. In the new study, the team analyzed collisions of protons, which has been accelerated to high speeds and slammed together at the Large Hadron Collider in Geneva. Using data from the CMS experiments there, the researchers studied the entropy resulting from entanglement within the protons. Entropy is a property that depends on the number of possible states a system can take on a microscopic level. An analogy is a deck of cards. A shuffled deck has multiple ways that it could be ordered, whereas an ordered deck, a deck that's cooked or stacked, has only one. So the scrambled cards have higher entropy. It's kind of like what they're trying to say, like all these random events that are happening. If you shuffle up the deck of cards, you know, there's going to be 52 different options that are going to be kicking out. But when we're talking about subatomic particles and like quantum mechanics, we're talking about like billions of things that are going to pop out. So you're going to have like a billion stack card deck that are all different. That's going to be going. But if you cook that deck and if you stack it a certain way, you can get, you know, ace of spades, 2 of spades, 3 of spades, 4 of spades, 5 of spades. So this kind of what they're trying to predict with these experiments. If entanglement exists within a proton, there will be additional entropies as the results of those linkages. The entropy can be teased out by counting the number of particles produced in each collision. The amount of entropy that the researchers found agree with the aspects of assuming the quarks and gluons were entangled. The workers report in their papers, which is now awaiting peer review before publication in the journal. The indications of entanglement is not yet defined, says theoretical physicist Theon Forchinger, good lord, from the Heidelberg University in Germany, who is not involved in the study. This is cracking me up. They have like multiple people that they're citing, but none of these people are involved with the study. Come on, man. Get some of these people that are involved in the study. They probably aren't going to be able to talk about it till the peer review gets published. More than likely, that's the reason why. They're just talking to fellow researchers on this subject. So, more you know. Strict tests are needed to rule out possible explanations. Instead, he says, the researcher's study is more of a door opener that could lead to further research that could clarify the internal psyche of protons. One puzzle that future work could tackle is why quarks are always confined within larger particles and are never seen on their own. That confinement is the ultimate example of entanglement, says theoretical physicist that works at Stoneberg University in New York. Sorry, buddy, I'm not even going to try to pronounce your name. A co-author of the study, quarks similar cannot exist as isolated states, he says, and are always connected with their companions. Although this property of quarks is well known, there's no fundamental mathematic explanations for it. He hopes to study quantum entanglement in protons and could help explain this conundrum. So boom, there you go. I hope you like it. I hope that makes sense to you. I always dig this kind of stuff, the whole quantum mechanics thing. You know, I really think that my interest in quantum mechanics stemmed from the first Men in Black when Will Smith is training and he shoots the girl that's holding the quantum mechanic book instead of shooting all the different aliens. I really think that's probably where I started my joy of all this crazy science stuff. I'm just kidding, total joke. But there you go, that's the video. We got quantum entanglement, talking about quarks and why they're always connected with something else. So hopefully this research that they're doing in Geneva and slamming these particles together to see how the deck of cards, if it's going to stack out depending on how many protons, neutrons, the quarks that are in the actual atoms and molecules that are being collided, to see if that like stacks the deck of cards a certain way, or if we're just going to get randomized results over and over and over again. So, Buddha boing, there you go. Core with File Notice Media. I hope you like it. I hope the hat works with the green screen. We'll see. Maybe I'm going to have an invisible head. Anyway, thanks for watching. Have yourself a great day.